Hello my dear student, I am Professor J.P. Shukla, and in this video we will discuss about the properties of Laplace transform part 2. Now we are discussed in our previous video the first three properties of Laplace transform, and now in this video we will continue our next properties from 4 to onwards of Laplace transform. So now let's start. Now next is fourth one. The property is that multiplication by t raised to n. Now see that if Laplace of ft is any function of t and its Laplace of ft is fs, then the Laplace transform of t raised to n into ft means when we will multiplying ft by t raised to n, then its Laplace transform becomes minus 1 raised to n into nth derivative with respect to s of fs. That is the property of multiplication by t raised to n. And now this property I will explain to you by taking one example here. So now see that. For example, suppose we have to find the Laplace transform of sin t into t. Now let ft is sin t, because the multiple of t is here sin t, so the multiple of t function is sin t, we will take that is as ft, and the Laplace of this ft, that is Laplace of sin t, is we know that a upon means a is here 1, so 1 upon s square plus a square means 1, and now say it is fs. And after that, by using this property of multiplication by t raised to n, therefore Laplace transform of t into sin t. Okay, so it becomes minus 1 raised to 1, because t raised to here 1, so it becomes in place of n is 1, and derivative, first derivative d upon ds of fs, our fs is 1 upon 1 plus s square or s square plus 1, and now it becomes minus 1 raised to 1 is minus, and derivative of 1 upon 1 plus s square is minus 1 upon 1 plus s square its whole square into derivative of 1 plus s square in multiple form, that is 2s. So finally the Laplace transform of t into sin t becomes minus into minus plus 2s upon 1 plus s square and its whole square. That is the required value of the Laplace transform of t into sin t. So that is the basic example of this property, and dear student, you will take more problems based on this property, and you have any doubt and any query, then you can send your doubts in our comment box of this video. And now our next property is, that is fifth one, division by t. If Laplace of ft is fs, then Laplace transform of ft divided by t is the integration of fs. Fs is the Laplace transform of ft from the limit s to infinity, where s is the parameter, we know that in the Laplace transform. And I will explain this property by taking an example here. Now suppose we have to find the Laplace transform of the function sin t divided by t. The first step is that if function is divided by t, so we will take the ft as numerator, that is let the function ft is numerator sin t, and Laplace transform of this function ft means sin t, we know that the Laplace of sin t is 1 upon s square plus 1 square means 1, and now say that is fs. Okay, because Laplace transform of sin at is a upon s square plus a square, and here sin at is 1 and t is t. Okay, and after that we will applying this property division by t, so we get the Laplace transform of ft upon t, that is the Laplace transform of sin t upon t, that is the integration from limit s to infinity of fs, and our fs is 1 upon 1 plus s square into ds. So now see that the integration of 1 upon 1 plus s square is, we know that tan inverse s, and limits are s to infinity. And after putting the upper limit tan inverse s, because we are integrating here with respect to s, so we will putting this limit for s or in place of s. So it is upper limit is infinity, so tan inverse infinity, and minus lower limit is tan inverse s in place of s, so it is as it is. And now we know that the tan inverse infinity is pi by 2, because tan 90 is infinity, so its inverse value is angle pi by 2, and minus tan inverse s. So pi by 2 minus tan inverse s becomes cot inverse s, because tan inverse x plus cot inverse x is pi by 2. So we will find the value of pi by 2 minus tan inverse x or s, it becomes cot inverse s. That is our required Laplace transform of the function sin t by t. That is our required answer. So that is the fifth one property, division by t, and both fourth and fifth properties are very important properties in the Laplace transform.